So we're in Geometry, Chapter 7, Section 4. Before we talk about the parallel lines and similar theorems, just a couple things to go over. And the first one is this. If we know the proportion A to B equals C to D, cross products, AD, BC, then is A over C equal to B over D? So are they equivalent? So that's where we check cross products. Here, we already know. That's given from our notes from before, but look at we do these cross products. So they do check, so they are equivalent. So what's all purpose of this? You're going to find there's more than one way to set the proportions up. More than one way to set up a proportion. More than one way to do it. Okay. So then that leads us to this question. Oh boy. So it leads us to this question. If A over B equals C over D, then is this equivalent? A plus B over B, C plus D over D. Are those equivalent? What's your cross product here? AD, BC. Can we get this to look like that? So let's check. Do your cross products. So we gotta go here, and we gotta go here. Again, you're calling how you want to do it, but we have two terms up here, so we have D times the quantity of A plus B. Two terms up here, B times the quantity of C plus D. So distribute. So we get AD plus DB equal to BC plus BD. But is BD the same thing as DB? They absolutely are. So in fact, we do get that. Now, does that mean anytime I see that? No, that means this is how we check. Because there's going to be some problems where they don't equal to each other. Point being, check. Make sure you're checking. So now we get into our theorem. If three or more parallel lines are cut by two transversals, we're saying that the transversals are going to be cut proportionally. Parallel, parallel, parallel. And we've got two transversals. Let's see, one goes here, one goes here. Call that A, B, C, D, E, and F. Okay, so what we're saying here is no guarantees that they're equal, but we're saying this and this are being cut proportionally. So a couple things we could set up. again, the transversals are being cut proportionally. So we can say AC compared to CE equals BD compared to DF. Look at the comparison I made. I went top of transversal to bottom. And top to bottom made the same comparison. You've heard that phrase, make the same comparison. Another thing you could do as we do this, since we're making the same comparison, we could go AC to BD. And we could say CE compared to DF. Notice how I did the comparison there. I went left top to right. There got to be corresponding positions here. So we went left to right. Make the same comparison. Making the same comparison. So let's try an example that looks like this. Let's go. Got the big triangle here. This, you're being told parallel, parallel. This is 8. This is Y. This is X. 5, 10, and 12. All right, you got to find X and Y. So what's this going to do? Well, this is going to incorporate a couple things that we've done already. One being today. So we're going to consider parallel, parallel. So here's your transversals. That side and that side. So let's use that to figure out what we have going on here. Let's find X first. I'm just going alphabetical, so I'm going to make a comparison. I'm going to go 10 to 5. And from 10 to 5. Sorry about that, had to pause. So as we're setting this up, here's our transversal being cut 10 to 5. So I'm comparing top to bottom. Here's my other transversal. I'm going to be going top to bottom. So that's going to give me 10x equals 60. Now some of you might have seen divided by 2 to get the denominator. Same deal. So there's the parallel and cut by transversal. Now, this is part of a parallel. So this one's going to be a little bit different in terms of finding y, but if you look at your two triangles, I'll write that here. 10, 8, 12. Big triangle, together 15, together 12 plus x doesn't help us much. Well, we already know what x is. And we got to find y. So one option is to this is congruent by the reflexive property. So the triangles are similar by angle-angle similarity, parallel lines, corresponding angles. So I can do this if need be. I can go 10 to 15 equals corresponding 8 to y. Now some people reduce this. You don't have to, but some people will. That's going to give me 10y equal to 15 times 8. Come on, I'm waiting for the answer. Anybody? Oh, that's right, you can't answer me. 120. Y is equal to 12. So combination of what we had from the last lesson, and a little bit of what we have going on this lesson. One more example, if I'm not mistaken. Okay, last example, then we look at this situation. So, you've got your three parallel lines. Here's your two transversals, but now we've got 2x plus 1, we've got an x plus 7, 3y plus 8 for here, and then a y plus 5 for this section. So, I look at it. Okay, I can set this ratio up to this ratio. We're going to have two variables in the ratios. So that's going to cause a little bit of problem. So there's one piece of information I need to give you, and that is this. This transversal has been cut so those two segments are congruent to each other. So based off of the theorem that we're dealing with, if the transversals are cut proportionally, if this is cut and those two are congruent, what can you conclude about here? Hopefully you're answering that they're congruent. Not this way, but congruent, cut proportionally this way. So again, we're being cut proportionally this way, which then allows me to use my same variables since they're equal to each other. Subtract x from both sides, subtract 1 from both sides. And it also allows me to, again, because they're cut proportionally, if these two are congruent, those two will be congruent to each other. Not congruent this way, congruent this way. So that allows me to do those as we set this up. So I will have 2y equal to 13. Y equals 6.5. And again, you could plug the numbers in and compare this way if you wanted to, but you don't need to. If you really wanted to get, this is a 1-to-1 ratio, you can go 1-to-1 equals this to this, but you're going to end up getting here too. Cross products will get you right there. I just kind of cut to the chase.